So you're welcome to a step ahead from the previous lecture in fluids and hydrostatics. So we move on with the second example. This is really example 2. I've done the previous one earlier in the first video. Alright, so if I will crunch this, I'm actually looking out for the pressure from my hand on the book, that my hand exerts on the book. Alright, so I'm really taking the area, okay, at which my hand makes contact with the surface of the book. So the area from my hand is 0.06 square meter, and the force is really the perpendicular component of this force, which is the same as this, F cosine theta. And of course, this is also the same as F times the sine, but I have to take 90 degree minus theta. So any of these two terms boils down to the perpendicular component of the force. And this is also the same as F times the cosine of open bracket 90 degree minus theta. So any which one is fine. So let me now look out for the value of cosine 40 degree. Cos 40, cosine 40 degree. Alright. So to start with, I have 60. I'll keep the units afterwards. Times cos 40 is 0.7660. The 4 decimal place here. The unit I have is knitting up here. Then I have 0.06 is square meter. So we could also call this Pascal for my convenience. So you need to beam this for a while. Okay. We need to clean this up for a while. So you're beaming this for a while? Alright. So let me clean up this now, because I still really need to work with this. So 60, the term we have there, 60 times 0.7660 turns out to be 45.96. So I'm still particular about the pressure from my hand on the book. So the time we have up there, the numerator is 45.96 Newton. Then I'll divide this by 0.06 square meter. This is also Pascal. So just to get the job straight, 45.96 divided out by 0.06. Of course, the answer is a pretty straightforward answer, 766 Pascal. So this is really the pressure from my hand on the book, given the force of 60 Newton. Now we go to the second phase of, this is the first phase, the A part. We go to the second phase now. Now, the second phase is what is the pressure the book exerts on the table itself. So let me define the area of the book. Let's say this is the area of the book now, because this is the surface and this is the area of the table that the book makes contact with. So this is, let me say, is 0.012 square meter. All right. So you need to beam that for a while, so I could go ahead with the solving for the other one. All right. So all right. So I'm now particular about the pressure the book exerts on the table itself. All right. So let's break it down. To start with, the book itself has a mass, 0.5 kilogram. And of course, there is a downward force of gravity acting on it. So I'm really seeing a force of gravity pushing down on the book, which equals the mass of the book times the gravitational acceleration. So G is 9.8 meter per second squared. Okay, 9.81, and this is roughly 10 meter per second squared. So to get the job done now, I have the perpendicular component of the force that exerted on this given area of the book. But mind you, the table has to carry the force from my hand and also has to carry the weight of the book itself. So I'll also have to add up the weight of the book, which is mg, that's the force of gravity on the book. Then I'm dividing this now by this area and the book makes contact with the table. So this is the area of the book. So to get the job straight, this is F. Earlier, I talked about the component of the force to be F times the cosine of theta plus mg, and I'm dividing this by the area of the book. So let me stick in the values now. The force is 60 times the cosine, the given angle there is 40 degrees, plus the mass of the book is half a kilogram, and let me use roughly g to be 10 meter per second squared, and of course everything here boils down to be in Newton. This is kilogram, this is meter per second squared, that's the same as Newton for a force. So Newton, and I'm dividing by the area, this area, and that's 0.012, and this is in square meter. So to get the job done, this comes out to be 60 times 0.7660, that's the same as cosine of 40, times 0.5 times 10 gives me a 5, and I'm dividing this by 0.012, and this would come out in Pascal. So this is really the pressure from the book on the table. So just to set the record straight, let me give the final results from here. This is 60 times 0.7660 times 5. This is really 229.8 Newton, and I'm dividing this by 0.012. So this is in Pascal, Newton Pascal. Let's use it in Pascal. So to give the final answer to this result, it divides 229.8 by 0.012, and clearly 229.8 divided by 0.012, and the answer boils down to be 19150 Pascal. So if you compare the area, it's still the same force. The area of my hand is this time, the area of the book that makes contact with the table is this. However, I also know how to factor out the force of gravity exerted on the book. So this is really the pressure that the book exerts on the table. So let's move on. So you need to bin this and this for a while.